is x squared minus 1 over 2x squared plus 12x plus 16. In this case, there's going to be 4 pieces. I'll just give you a heads up. Okay, so there'll be 4 pieces for you to look at. Okay, so I'm going to catch up. Maybe some of you are already there and some of you are just getting there, but may need a little bit more space on this one. If I was to take it into pieces, I would be talking about x minus 1, x plus 1, and then on the bottom, 2 times x plus 2 and x plus 4. So there's actually 4 pieces. A good question was asked, like, what about these constants? Well, this constant's positive, so I don't really need to consider it. But what would happen if it was a negative 2? Would it matter?
It's going to reverse the whole thing.
Yeah, then everything would be reversed because there'd be an extra negative in all of my pieces. The reason the positive doesn't affect it is because it won't change. A positive times a negative stays negative. A positive times a positive stays positive. So when they're positive numbers, we don't need to think about them, but the negatives we would. Okay, so we need 4 number lines in this case. 1, 2, 3, and 4. My pieces, just to help me keep track of what I'm doing, are x plus 1, x minus 1, x plus 2, and x plus 4. So I'm going to have 4 places that are of interest to me, and that happens at negative 4, negative 2, negative 1, and positive 1. And if I whip through these trying to figure out their signs, it'll be positive on this side, negative everywhere else. And again, there'll be positive, negative everywhere else. So I can finish this off fairly quickly. And at 4, this will be negative, positive here. Okay, so now what I want to do is take a look at what I've been given. All I'm interested in are the asymptotes. Remember, not all these pieces mark asymptotes. There's nothing wrong with negative 1 and positive 1 because they're on the numerator. That's okay. The problems, the asymptotes, happen on the bottom. So that's why I'm only interested in these 2 positions. So really, I don't really care about the extra pieces here. I don't have to fill in all of the positives and negatives. I could just stick with the ones that have to do with the asymptotes. So here, that's going to be a positive. This is going to be a negative. And this would also be positive. I don't need to keep going because, again, that covers all the asymptotes I was looking for. So as I approach negative 2 from the right side, that's here. Those are the positives. This would be infinity. As I approach negative 2 from the left side, that would be the negative side. So it would be negative infinity. Similarly at 4, as I approach from the right side, this is going to be a negative. This time I'm going that way. And as I approach from the left, it's going to be positive infinity. Okay, so I'll let you copy that down if there's anything else that you needed to catch. All right, so let's so what you should be comfortable doing now is identifying the asymptotes and finding the left and right side limits of the asymptote. So this time I'm not telling you where they are. I'd like you to just try, let's say we're going to do the first one and the last one. We won't do too much repetitive, but let's try the first one here and the last one here, and we'll see what you come up with. Again, all I want to know is where are the asymptotes, and what are their limits on the left and right hand side. Okay, so whether you choose and you see it's necessary to do a number line, or maybe you have some other insights into it, as long as you can do it without your graphing calculator to show you, that's fine. I'll give you another minute if you need to work on the second one, but hopefully we can talk about the first one by now. If you really quickly had to sketch this and just try to think about what the proof, or sorry, the asymptotes would look like, negative 1 is where it's going to happen. That's where I divide by 0. That's where I'm interested in where the sign changes. It will be negative on one side, positive on the other. So that means as I approach from the left, it's going to be negative infinity because I'm in the negative side. Okay, so left is going to be negative infinity, and as I approach from the right, it's going to be positive infinity, approaching from the right. Okay. Now maybe we need a little scaffolding to get started on this cotangent business. So, cotangent. Wait a minute, there's no fraction there. How are we supposed to use all that stuff with fractions? What? Anybody have any suggestions? Just give up? Graph? Yeah, the graph could help us, but again, our goal is trying to do it without the graph. Yes, Joy? Brilliant. So its cotangent is the same thing. We could rewrite this as cosine x over sine of x. Okay. So where does the what's going to cause the asymptotes? Can anybody explain that? Sure, Jackie. Yeah, when the sine x equals to 0, if this bottom piece equals 0 and the top does not, then we will end up with asymptotes. Okay? So let's think about that. We've got two pieces here, cos x and sine x. Now you'll notice in this instance we're only looking on a very small interval, so I can actually revise this. It's not really a full number line, it's more like one of these number lines where you go like this, and you just go from 0 to pi. So where does this is going to be a confusing sentence, where does the sine change its sign? Did you follow that? Where does the the sinusoidal graph sine change its, no, that's not going to work either. Okay. Where does the sine change its sign? Let's just stick with that. Did you want, go ahead, Jackie, explain what yours. You're correct. It doesn't change in this instance. Why? Those are quadrants 1 and 2, right? So quadrants 1 and 2, the sine graph is always positive. So this is always going to be positive. What about the cosine graph? Where will the cosine graph change from positive to negative? Yeah, pi over 2, that's where the quadrant changes, so that's a good place to mark on here. Okay, if I'm from 0 to pi over 2, that's quadrant 1. It would be positive. It changes over here to negative. Okay, so that's what my picture looks like this time. Where are the asymptotes going to be? Can somebody give me a value of x where we would find an asymptote of the cotangent? You guys take a break. How about David? Anybody want to help out? Close. Want to revise your answer? We're talking about problems that happen here. That's where we're going to have asymptotes. Has it been that long since we did trig? Yeah? Pi? Yeah, pi is one of them. Perfect. So at pi there'll be an asymptote, and the other one is going to be at somebody else? 0. Yeah, I did. Okay? So there's going to be asymptotes right at the borders, right there. Okay? We want to figure out then, as I approach from the left and as I approach from the right. Sorry, I did that backwards. As I approach from the right of 0 and as I approach from the left of pi. Okay? So as I approach from the left of 0, it's going to be positive infinity. As I approach from the, no, I did it again. You think I know my left and right arms by now, but apparently I don't. So this would be from the right side of 0, and this would be from the left side of pi. It would be negative infinity. Okay, apologies. I will try to stop mixing up my right and left hand from now on. Okay. Any, that one is a little bit trickier. Obviously, we're not dealing with simple polynomials, but no, we don't need to think about where, that's a good question. We don't need to worry about the left side of 0. It's not in what we were given as a domain here. So don't worry about it, it's outside the range we're looking for. I'm just going to consider the number line as I wrote it from 0 to pi.